That's true. Tomorrow I'm gonna go to the gym. Try to get my shit done in the afternoon, and then maybe if you want, we could all hang out in the evening. Something like that. If everybody's down, I don't want to, force anyone to.
Alright, I'm just gonna start the video. Hello guys, so today we're going to be talking about circular integration, and this is kind of like a variant of integration by parts. This is certainly a kind of problem that you're going to come across when you do integration by parts. It is just one of the many different skills that you should pick up in this class. And so let me actually just start just straight up with an example and then just talk a little bit about why it works. So we're going to be taking a look at the integral of sine of 5x times e to the 2x dx. Okay, so one thing I want you guys to notice very quickly is that both of these have repeating derivatives and integrals. What does that mean, you might ask? When I derive a function like e to the 2x, I get 2e to the 2x, then I get 4e to the 2x, 8e to the 2x, and so on and so forth, right? It kind of just keeps going, cascading down. With sine of 5x, it's going to become 5 cosine of x, then it's going to become negative 25 sine of x, sine of 5x, and it's going to keep going like that. So if you use the integration by parts formula, you're going to get a little bit confused perhaps. So let me walk you through how exactly this works. So in previous videos, I showed you how we choose our u and our dv, and we're going to do the same thing here. Let's choose our u to be sine of 5x, and then we'll take our dv to be e to the 2x dx. We can integrate that pretty easily, and we can take that to be 1/2 e to the 2x. That's kind of just a standard integral. And then we can do our du, and that's going to be equal to 5 cosine of 5x. Don't forget about your chain rule, guys. So now we have all of our values, and it's looking pretty good. So let's just plug them right into our little equation. So now we have 1/2 sine of 5x times e to the 2x minus the integral of v du, and so that's going to be minus 1, or sorry, that's going to be minus 5 over 2. And actually, I'm just going to bring this 5 over 2 out right now. Five over 2, we're going to have cosine of 5x e to the 2x. Yeah, sorry about that. That's a little bit mixed up in there. So now let's take the integral of cosine of 5x e to the 2x. And so just like this previous example, we're going to be using our integration by parts method. And let's use the same u's and dv's generally. So we're going to have our u be equal this time to cosine of 5x. And then as a result, our du is going to be equal to negative 5 sine of 5x. Our d, and we're going to put a dx over there. Our dv is going to be e to the 2x dx. And then our v is going to be 1/2 e to the 2x, just like before. Okay, so now after all of that, we can do our uv, and that's going to be 1/2 cosine of 5x e to the 2x, and then it's going to be minus v du, but we already have a minus here, so it's going to be plus 5 over, and here it's also, again, it's going to be important for us to bring this out, 5 over 2 5/2 integral of sine of 5x e to the 2x dx. Now for those of you that are watching patiently, and for those of you that are watching attentively, you might recognize this somewhere, and that's because that's the exact same integral we began with, right? Sine of 5x e to the 2x. Now, this is where it becomes really interesting, actually. We're gonna actually almost rewrite this whole thing as like a variable equation, and this is going to be we can almost think of that like as a variable, like y or x. So we can rewrite this whole thing, and this is where you need to be very careful about your work. Make sure you have neat work so you can keep track of everything. And we can rewrite it as the integral of sine of 5x e to the 2x dx is equal to, we're going to have 1/2 sine of 5x e to the 2x minus 5/2 times, and so here I'm just going to do a little bit of distributing, just like that. You guys can always double check the math. Hopefully I don't make any errors. So it's going to be minus 5/4 cosine of 5x e to the 2x minus 25/4 integral of sine of 5x e to the 2x dx. Okay, now that we have this equivalence, we can add this 25/4 to both sides. So from here it's going to cancel out, and then on our right side we should have 29/4 times the integral of sine of 5x e to the 2x dx, right? So this is 1, which is equal to 4/4. We just added that over there. And we know that this is equal to, I'm just going to set this down here because we're kind of running out of space. So what I'm actually going to do is I'm going to write out this whole thing is going to be equal to 1/2 sine of 5x e to the 2x minus 5/4 cosine of 5x e to the 2x, all in parentheses. Now the last step we want to do is we're only solving for this integral. We don't need this constant at the front. So we're just going to take the reciprocal of that to kind of undo it. And it's going to go to 4/29. So finally, we have our answer. Let's put the plus c at the end. And this is it. Yeah, this is a lot of work for this problem. So this is generally how all circular integration problems are going to go. You can tell very quickly if you're going to have to use it if you have two of these repeating functions. If you have sine of x times e to the x, cosine of x times e to the x, those are our two classic problems we're going to be using this method. And like I said, it is a lot of work. So definitely double check your work on all these. Make sure you didn't make any small algebra errors, because these kinds of long these kinds of long problems can be quite error prone. So be careful. But yeah, that is the way that we solve these kinds of problems. Hope that video helped, and yeah, look forward to making more videos and seeing you guys soon. Thank you. Hey, Schlot,